Hurricanes, also known as tropical cyclones, are fueled by warm ocean water and develop through a cycle of stages, beginning with a pre-existing weather disturbance. The process transforms moist, warm air into a powerful rotating storm system. Several environmental factors must be present for a hurricane to form and strengthen. Warm ocean water. The sea surface temperature must be at least 80 degrees Fahrenheit, 26.5 degrees Celsius, extending to a depth of about 200 feet, 60 meters. This warmth provides the massive amount of moisture and heat energy needed to fuel the storm. High humidity. The atmosphere must have high humidity levels, particularly in the mid-troposphere. This moist air feeds the storm and allows for the formation of large thunderstorm clouds. Low wind shear. Wind shear, or the change in wind speed and direction with height, must be low. High wind shear disrupts the storm's structure and prevents it from organizing and intensifying. A pre-existing disturbance. A hurricane needs a seed to start from, such as a tropical wave or a cluster of thunderstorms, which provides the initial low-pressure area. Location away from the equator. The storm must form at least 200–300 miles north or south of the equator for the Coriolis effect to be strong enough to initiate its rotation. A hurricane's formation is a progression through several distinct stages, each marked by increasing wind speeds and organization. 1. Tropical disturbance. This is the birth of a hurricane, where a cluster of clouds and thunderstorms with a slight wind circulation forms over tropical waters. A tropical disturbance may maintain its identity for at least 24 hours and is often accompanied by heavy rain. 2. Tropical depression. If the disturbance organizes into a closed, rotating wind circulation and its sustained wind speeds reach 23–39 miles per hour, 37–63 kph, it becomes a tropical depression. The central low-pressure area begins to draw in more warm, moist air, strengthening the system. 3. Tropical storm. The system is named when its sustained winds increase to 39–73 miles per hour, 63–118 kph. At this stage, the characteristic spiral bands of thunderstorms begin to form and grow more organized around the low-pressure center. 4. Hurricane. Once sustained wind speeds reach at least 74 miles per hour, 119 kph, the storm is officially classified as a hurricane. The storm continues to pull in warm, moist air, releasing latent heat as the water vapor condenses. This heat energizes the storm in a positive feedback loop, causing it to intensify and rotate even faster. The rotation of a hurricane is caused by the Coriolis effect, a phenomenon created by Earth's spin. Effect on wind. As the storm's central low pressure draws in air from all directions, Earth's rotation deflects the path of the incoming winds. Northern Hemisphere. In the Northern Hemisphere, this deflection forces the winds to curve to the right, causing the storm to rotate counterclockwise. Southern Hemisphere. In the Southern Hemisphere, the winds are deflected to the left, causing a clockwise rotation. No rotation at the equator. At the equator, the Coriolis effect is too weak to induce a rotation, which is why hurricanes cannot form there. In a mature hurricane, the following distinct features develop. The eye, a calm, clear area at the storm's center where air from high altitude sinks and warms. It is a deceptively tranquil region in the middle of the violent storm. The eye wall, a ring of intense thunderstorms immediately surrounding the eye, where the storm's strongest winds and heaviest rainfall are found. Rain bands, bands of clouds and thunderstorms that spiral out from the eye wall, contributing to the storm's heavy rainfall. A hurricane weakens and dissipates when it loses its source of energy from warm ocean water. This occurs when the storm makes landfall or moves over colder water. Friction with land and a lack of moisture disrupt the system, causing its intense winds and heavy rains to subside.